Hello everyone and welcome to today's class. Today we're going to talk about a brand new JavaScript feature called Decorators. That is a function that you use to decorate classes and making the different parts of the class perform different tasks. It's a little bit difficult to explain without showing you, so I will show you an example to begin with. Here is a sample class. It's called my class and it consists of two different methods, which are just regular functions. We have my method and it takes in an argument and just prints out a message. And then we have another method which doesn't do anything. So imagine we have a lot of these different classes in our project and we wish to enable some kind of logging. So for each and every method we want to perform a similar task. How do we do that? We could go into every single class and do something like console.log and then my method something like this, and then you go into this one and you do console.log and another method logs. This is a very simple example. You can do a lot of different advanced stuff, which we will be doing in this episode or in this series rather. But this is a simple example. Okay, so what if we have hundreds of different classes and we want to perform similar but not exactly the same functions or log messages or whatever on each and every method? So we can't really do this. It will take too much time and be too tedious. Then we can use decorators. Let's just say we have a decorator called log. So then we do an @ log, and it should be one step. Before I could just move one line at a time. There we go. And then we add it to the other one as well. So this is how a decorator looks like. You do a @ and then the name of the decorator, and you do it just below, just above the name of the function or the method in this case. You can also put it like this, but usually it's done like this for methods. You can also have a decorator for the entire class, and you can have it for individual arguments as well. But you usually have different names of these for the different levels. So what is a decorator? How does it know what to do? Well, a decorator is actually a function which returns a function. So this method right here, this is a function. So when we call this decorator, it will return this method or a modified version of it. So let's define this log decorator, we just do something like this: function log, and then we let this function return another function. And the contents of this function is this method. We do also have two arguments that we can use. So we have a target and we have a context. So the target, that is the original function in this case. So what we could do, we could just comment this out and we could do return target like this. And then that means we would return this original function unmodified. But if we do want to change this one, then we return a new function like this. We can still call the original function, so we don't need to put in all the code which is already here. So we call this original function, but before we do that, we console.log. And let's begin by doing no, let's do it the proper way. I will create a template literal string, and I will put in the name of the method, just like we had in our example before, and then logs. So what do we put here? We want the name of the method, and that's where the context comes in. The context have a couple of helper variables, functions, and one of them is name. So this will translate to my method logs. And that's all we need to do. We can do a lot more advanced things. We should also put the original argument here, because this method takes in an argument, so we should pass that along as well, like this. We can do a lot of advanced stuff, and we will later use these methods to create a small framework for creating a command line interface based on decorators. But this is a simple enough example. So we have the decorator, which is a function that takes in two arguments, the target and the context. And the target is the method or the thing we are decorating. Could also be an argument or a class. And the context is a helper object with a couple of variables and functions that we can make use of to create better decorators. And then we return either the original function unedited by returning the target, or we return a new function which replaces this whole function. So what we return right here will replace the entire content of this one. And in this case we console log and then we call the original function. So basically we add a log line of code before this line. Okay, so this example is just for showing you how it's done. I haven't set up my environment yet. I will do that together with you, so you also know how to set up an environment, because this is a brand new JavaScript feature. So it's, as you can see right here, it's not very supported yet. But there are ways to go around that. If we install TypeScript, we don't need to code any TypeScript. I will only code pure JavaScript in this course. Perhaps at the end I will show you some TypeScript features with decorators, but 95% will be regular JavaScript. However, the same feature, exactly the same implementation of the decorators feature in JavaScript has been enabled in TypeScript. So I will show you how to configure an easy enough installation of TypeScript so you can use decorators for your JavaScript code. Welcome back everyone, and welcome to today's lecture. Last time we talked a little bit about JavaScript decorators, and today we're gonna test them out. In order to do that, we need to set up our environment. We need TypeScript to be able to use the decorators, at least for now. The function will come to all the web browsers and to Node.js in a little while. Maybe it works in the browser when you listen to this video, but at this current date, the beginning of February 2024, you still need TypeScript in order to use this new JavaScript feature. However, we are not gonna be coding any TypeScript. We will just use regular JavaScript, however, in a TypeScript environment. So, in my case, I am gonna install things on a Linux server, a VPS, a virtual private server, but you can install it on your local machine. It will basically be the same thing. There is one more step for me, but you can just ignore that step. Okay, so the first thing, I will create a folder, and this project will start as an example. The log method we talked about last time, but it will turn into a small framework for creating command line interfaces. So I will just call this project CLI. So I create a directory for the CLI and I go into that directory. Then we initialize one more thing. You need Node.js installed to get this to work. You probably have that already, but in case you don't, you go to nodejs.org and you download and install the LTS version, long-time support. I have already that installed, so I will do npm init dash yes, and that will initialize our project and create the package.json file which is needed. Now we're gonna install the libraries we need, and that will be TypeScript, and we will also need a couple of types packages, one that's called types node and one that's called TypeScript, like this. And my plan is to do the most minimal configuration of TypeScript, and then we will add configuration variables when we need them. Okay, so now I have installed TypeScript on my server, and you have probably installed it on your local machine. The next step is only if you have installed it on a separate server. I'm gonna start a program called Sociopath SCP client, and it's a tool for uploading files to a server through the SSH protocol, the same protocol which is used for this communication with the terminal. And it's really nifty because you can open up a remote folder on the remote machine, and you may edit your files remotely, and it will automatically update when you create new files and when you alter the files. Okay, so let's go into the code, and here is my new project. So I right click and I choose open in editor. So now it will automatically download all the code files in that directory and subdirectories and open it up in VS Code in my case. And if I were to, let's say, create a new file, index.ts, and type something here, console.log test, and I save. There, it automatically updated. So now I can just minimize this and work entirely in my VS Code window. Okay, so what do we want to do here? Let's open, by the way, you can also open up the directory in VS Code, but locally on your machine if you don't use a virtual server like me. So then you can just type, on most systems you can type code dot and press enter, and it will open up the VS Code editor in the current directory. If that doesn't work and you are running a Mac computer, you can do open -a code dot. You can also use the menus. When you have entered that directory in your code editor, you can open up the package.json so we can prepare our build script. there is a test item here in the scripts object, so let's change that to build, and as a build command we will just run tsc, the TypeScript compiler, which will transpile our TypeScript code, which in our case is just regular JavaScript code, until a JS file. And we can also add in a start script. Probably not going to use that, but it's always good to have that. And we will just run node index.js, which is our output file. And let's save this one. Okay, that's enough for now in this file. We also may need to change something in the right. We need to initialize TypeScript. I forgot that. Let's do it like this. I will close down this one. Close folder. And I'll go back here. And then we will run npx tsc -init, which will initialize TypeScript and create a TypeScript configuration file, tsconfig.json. And we'll reopen that directory. I could have just opened the file here, but I want it to look as much as your screen as possible. And CLI, open an editor. And there we go. So this time I want to open tsconfig.json, and I will make a little room. I hope this is not too tiny for your screen. And there is a couple of things we will alter in this file, but as of now we will just do the bare minimum so we can make this run. So let me see. As you can see, most of these settings are commented out, but we do need, if we search for decorator, then you will find this, experimental decorators, true. If you remove the comments and you change this to false, because the experimental decorators is something which is called stage 2 decorators. It's an old standard that has been around in TypeScript for quite some while. We are going to use the stage 3 ES decorators, the ones that will come to JavaScript. So if we disable this feature here, then we will be able to use the real standard. Okay? Let's see if this is enough. So I will open this index.ts file and I will go back here and run npm run build, and this will create our index.js file. And if we open up that file, we can see it's basically the same as the one we have. So this is the one we're gonna run. Okay, so let us test this scenario that we had before. So if we create a sample class, my class, and we have a method, my method, with an argument, and let's just do a console log arg and that argument. So that is our whole method. And then we'll create another method, and this will just return void 0. So it will do nothing and return nothing. Okay, I don't think it likes the name argument. Let's do arg instead. Or is it something else? Ah, okay. We need to change one more thing in the configuration, because it doesn't like that we don't specify the type, and we are coding JavaScript, we are not coding TypeScript, so there are no types, which means we need to go into the tsconfig and search for implicit, and this one, no implicit any. We comment this back and we set this to false, like this. And if we go back here now, the error is gone. Okay, so here is our method. Let's initialize it in a variable. We can call it x. So x equals new my class, like this. And let's now see if this is working. Let's run npm run build. And it once again produced an index.js, which we will start by doing node let's dot slash it index.js. Okay, at the moment it's not doing much, but we can run this method, my method, on this object that we have created, like this. And then we run the build script once again, and let's start it out. Okay, so arg undefined, and if we put in an variable here, let's just say true or something, And we repeat this build process. Now we see arg_true. So this is a very simple class. Now let's create that log decorator that we talked about before. So as I mentioned, a decorator is just a function that returns a function. So this method, my method, it is also a function, and this is what the decorator will return in a modified version. So let's create that function. I usually do it like this. I do let and the name of the decorator. This is just a stylistic choice really. And then I do log equals, and I'll do an arrow function like this. And then on the next line, I will do another arrow function. And here we have two arguments. We do have the target. Let me just think. No, it should be up here. So the target and the context should be in the first function, and in the other function it should have the same arguments as the one we are mimicking. So we'll put in an arg right here, and inside this function we will put the logging. So let's just put in console.log, and then what did we do last time? I think we did say what function we are in. So let's do a template string, and we'll use the context.name just like before. If I may spell that, context.name. Inside context.name, and log like this. And then we want the original function, the original method to run, and that's our target. So we just do target, and we may use the same argument, and we can return this. In that way it will be exactly the same as the original one. So here we have our decorator. Okay, so how do we use this? On top of this, or next to this method name, we do an @ sign, and then we just put the name of the decorator like this. No parentheses or anything. So let's save and see if we can compile this, or if we do need to alter any more settings. I think it should be okay. Okay, no errors. So then we run node index.js again. And as you can see, inside my method log arg_true. So just by adding this log, we alter the original method. And we can do the same with this another method. So let's run that first. Another method without any argument. Save, and we build and run. Okay, it doesn't output anything, but it's running. And let's add this log decorator here as well. That's the only change we're doing. And as we can see, inside another method, it logs. So this is an excellent way if you want to add some features or some code to a lot of different methods. And you can also take it one step further, because in this case, let's say we want to add a custom prefix to our logs. Instead of this inside I have here, we should do different prefixes for the different methods. And as you can see, we can't pass any arguments from the decorator as of now. So how do we do this? How can we affect the decorator and its behavior? Well, we can, as you can see, we have two levels right here. We have a function that returns another function, but we can do one additional level. So just to differentiate, I will do it as a function declaration. So let's say instead of log equals this, we will just return this new function, and instead we will put the name of the decorator right here and make a function out of it. So this is called a factory function. The function has only one task, and that is to create another function. That's why it's called a factory function. So this one, let's do like this. Log equals function, so we don't get a conflict. So this is the decorator, and this is the factory function rather, and this returns the decorator, which returns the method that we are altering. So we just added one more level. And the good thing is we can put an argument right here. So let's say prefix. And we change this inside. And we put the prefix here instead. So now directly in the decorator, we may pass an argument. So let's say my method, we should just do log. And on the another method, we should do alert. So this factory function will return the decorator, which works like before, but with this prefix. So we're just adding a level so we can add a argument, a parameter. Okay, and now we are running the another method still. So let's see what it says. Alert another method log. And if we cycle back to our initial my method, and we compile and we run it. So now it says logged, and then it shows the output of the function. I will just say one more thing. We can also, if we decide to, let's say we have an I'll just say it like this. Here we are returning the function, the method. If we want to, we can not return anything. And why would we do that? Well, let's say we wanna, if some condition is true, then we wanna alter the method or the class or the argument. You can create decorators the same way for these entries. So if you don't return anything, then you leave the original method alone. And if you do return something, then you replace the entire method. So that's the basics of decorators. In later episodes of this series, we will create something more advanced, a more real-world kind of example of how we can use decorators. We are going to create our own command line interface framework. So it's a framework for creating command line interfaces projects. And it's a small framework, but it's gonna work. If you want more videos like this, please subscribe and like this video. And thanks for watching. Thanks for today.